Good morning, zoology class, and welcome to your lecture today on chapter 27, which is going to be mollusks and annelids. So let's get started. And one of the things that I'll really want you to keep track of as we move through this presentation is with our different classes of mollusks and annelids, how are they the same and how are they different? So one of the ways that mollusks and annelids are similar, and actually one of the reasons that we present them together, is because they both start with this larval form called a trochophore. And it's actually, again, you guys know I love to dive into like Greek and scientific meanings. So uh, for the phore means the bearer of or the bringer of, and trocho actually means wheel. So if you see that dark center in the middle of that little larva there, that is what we were talking about, that wheel bearer. Um, so yeah, just my little nerdy introduction for you guys. When we talk about mollusks and annelids, they are some of the earliest life forms that actually have a collimate body plan. Uh, so again, you might want to refresh what that means. Again, a true coelom is right in the middle there on our little picture, um, where the mesoderm connects all the way to the ectoderm and the endoderm, and you actually have this true body cavity or that coelom right there. So mollusks are going to have three main classes that we are going to talk about. So the first one is gastropoda, and that's going to be our snails and our slugs. So if you can picture a snail, you can picture a gastropod. Our second is going to be our cephalopods, and we've already talked about cephalopods a little bit because we've talked about cuttlefish, but also octopuses, squids, things like that. And finally, we are also going to have our bivalves. So that's going to be our scallops, our oysters, our clams. And you guys have already dissected one of these, so you should feel hopefully a little more comfortable with some of the internal anatomy of our clam here. And obviously the external anatomy too, when we're talking about the umbos and the hinge, our growth lines in our shells, things like that. But let's dive into mollusks. Uh, Probably the most important trait for our mollusk is the foot. And all mollusks are going to have a foot. It was very obvious to see in our bivalve that we dissected, but I want to remind you guys that a nautilus, an octopus, a squid, cuttlefish, all of those are going to have that muscular foot that they use for motion. And again, remember a cephalopod means a head foot. So the foot might not be where you think it is, but all mollusks have a muscular foot for locomotion. They also have the beginnings of a more pronounced nervous system, uh, what we call their ganglia, or just one of them would be a ganglion. But those ganglia, those nerve fibers are spread out throughout the entire body of mollusks, and they're able to react very quickly because of that. And muscles are able to flex very quickly. Again, think back to the cuttlefish and the type of camouflage that cuttlefish was able to produce by flexing and contracting those different little color spots on its skin. And also the shell. So a big question for you would be, do all mollusks have shells? And I'll leave that one for you guys to answer. And lastly, remember that mollusks are collimates. Now, one of the big differences is for bivalves and gastropods, they're going to be open circulatory systems. And a cephalopod, our head foots, are going to be a closed circulatory system. We'll talk about what that means in just a second.